So far we've been dealing with circuits in a series. So we have a resistor here, 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 like this. R1, R2, R3. And R total is R1 plus R2 plus R3. This is a series circuit. Current flows evenly through. Boy, I've got to learn how to write. I get in a hurry. R total is R1 plus R2 plus R3. The current is the same through all elements. Now we're going to talk about parallel circuits. This is always have trouble with this word. Parallel circuits. In a parallel circuit, all of the elements have common nodes on both sides. V total, R1, R2, R3. Unlike a parallel circuit or series circuit, whereas the currents are the same, in a parallel, all of the voltages are the same. VR1 is equal to VR2 equals VR3. So parallel, voltage is the same. Series, current, the same. If we look at this, we're going to generate a current, but it's going to come in here. Well, part of it's going to come here, and part of it's going to come here, which will get further split here and here. Now, how do we determine that? The definition that we use for our total, we still need to work this so that we get this down to one resistor on R total and V total, so we can at least find our starting current. In a parallel circuit, 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3, etc., etc. Now, you can use that form, or you can use R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. It means the same thing. How to calculate that? Use your calculator. If you're using, we'll put some numbers on it to make it a little easier. Okay, let's go. We'll just do a 2 resistor, 10 volt, 1K, and 5K. Okay. Oops, where'd you go? There we go. My R total can be calculated as either 1 over R total, which is 1 over 1,000, plus 1 over 5,000, which is 1,000. 1 over R total is 0.001 plus 0.0002. Did I miss that one? No. which is 0.0012. And I take 1 over RT, multiply both sides by RT, divide 1 by 0.002, and I get 833.33 ohms. It is important to remember in a parallel circuit, R total will always be less than R1, R2, etc., etc., etc. It's always going to be less than any of those. Okay. Now, we don't explicitly state it, but in series, just by its very nature, R total is going to have to be greater than the R1, any one of those. Whereas this one, it will be less than any one of those. So there's at this point, I know that my R total is 833. Oops, where did my 8 go? 33 ohms. And if I'm at 10 volts, that means my current is 12 milliamps. So 10 volts divided by 833.33 is going to give me 0.012 amps. Since I'm ohms and volts, so 12 milliamps. Now here I have to go back to here. Let's put this in red. I get 12 milliamps here. Well, a portion of that has to come here, and another portion has to go here. Which portion where? Well, since my voltages are the same, 10 volts there, I can just do my calculation. 10 volts divided by 1K is 10 volts times 10 volts divided by 1K is going to give me 10 milliamps there. 10 volts divided by 5K is going to give me 2 milliamps. So I'm going to have 2 milliamps coming this way, 10 coming this way, and when they get to this point, they get back to 12 milliamps. They add up again. Now let's try another one with 3 resistors. I'm going to go 12 volts. So R1, R2, R3. And let's say R1 is 770 ohms. R2 is 880 ohms. And I'm just pulling these numbers out of midair. They may not be real numbers or not, but just pulling them out. 550 ohms. Notice I'm doing ohms instead of kilo ohms now. So 1 over RT, or let's use the alternative formula. R total is going to be 1 over 770 plus 1 over 880 plus 1 over 550, which equals, when you do the math, 770 invert plus 880 invert plus 550 invert equals invert. I get 235.11 ohms. Let's check that again. 770 invert plus 880 invert plus 550 invert equals, and then invert, yep, 235.11. In case you don't know what I'm saying, when I'm saying invert on my calculator, I'm entering in 770, and then there's a key. It's like 1 over x. That inverts it. So 770 invert. And when I hit the plus key or equal key, I will get 0.0012988701. Same thing with 880. I hit that 1 over x key and then hit plus. Then I would get 0.11363636, and then 990, or 550 rather, 550. Then I press the 1 over x key, and this time I would hit just the x, just the equal. When I hit the and these numbers are when I hit the invert, not when I hit the add. I would get that, and then my total is grand total is 0.015941558, and I do an invert a final time. That's that 1 over x, one like half, 1 over x, and then that will give me, that gives me a wrong number, 770 invert plus 880 invert plus 550 invert. Yeah, that number was wrong. I got 0.04253.247. Hit invert there, and that gives me 235.11 ohms. And that's the number we're going to go with. So that gives me equivalent circuit. Come on. 12 volts of 235.11 ohms. So my current is 12 volts divided by 235.11 ohms is 51 milliamps. So now I got to go back. Now I go back up to my original problem. Draw it out again. Ah, come on. Whenever I try to make it nice and straight, it screws up. Where did it go? Well, it went away. It went away. There we go. I'm back now. There you are. Well, now I go back to my original equation. Oh, not equation. Circuit. And this one was 770, 880, 550. This is 12 volts. Now I know my current is 51 milliamps. So the current from here is going to be 12 volts divided by 770, which is 70 amps, 15.58 milliamps. So 15.58 of it is going here. That means coming out of this way is 51 minus 15.58, which is 35.42. Of that 35.42, I have 12 volts divided by 880 13.63 of, or 64 of that flowing down here. 13. Which means once I'm coming over here, my 35.42 minus 13.64 is going to give me 21.78 milliamps. Now, is that what I'm going to have? Well, let's calculate that. 12 volts divided by 550 amps, ohms rather. 12 divided by 550, and I see 21.818, which is close enough milliamps. There you have it. This is how you do parallel circuits. Now, when we want to talk about power, the power of the overall circuit is still going to stay the same. But now we're going to have the power, again, the power of R1, total power is going to be power R1 plus power R2 plus power R3. Same thing as it was in a series circuit. Well, think about it. In a series circuit, the voltages were changing, but the current stayed the same. In the parallel, the voltages stay the same, but the currents are going to change. So the same formula is going to apply in both scenarios. That sometimes will get you out of a jam when you've got to worry about some unknowns or something like that. We'll talk more about that in the next lesson or two. Thank you much. Have a good day. Bye now.